Good day. You will be looking at making molecular models on computer. This outlines the steps and words. It's pretty straightforward, and so once you're into it, if you have any problems, you can come back and read through this. And of course, you want the proper name, and you make a structural diagram, and then you try to make a sketch. I've still called it Willet, although you could go what it looks like on the screen, changing that T to an S, and deciding what gives you the best a view of it, but I'm going to go through and show you how to get into it and how to set things up. So here I just go and click Mole View, and once it appears, which it should shortly, you'll get this screen, and click Close. And this one happens to come with a pre-made structure that I don't want. And over on this screen, this is where you do your building, then you hit 2D to 3D to get your structure. So let's start with the first one you're doing. I click carbon, and now I drag from the carbon. And I make a line structure. And I have 1, 2, 3, 4, 5 carbons in that chain. And the first structure you're supposed to build is 2-methylpentane. Well, believe it or not, that should be 2-methylpentane. And there it is. This structure I have managed to convert like so. And all I'm doing is I'm clicking, holding, moving the arrow, and I can spin it. And when I use 2 fingers, I can zoom in, I can zoom out. And this is clearly emphasizing the tetrahedral shape. Now when you go for the next one, which might be 3-methylpentane, you can start from scratch, or you can simply put a methyl off the third and then use the eraser here to get rid of that carbon. And then it's 2D to 3D, and you can see now I have a methyl on the third carbon instead of a second carbon. Same deal. Now let's say I need to put in some functional groups, so maybe I've got a carbonyl group to put in somewhere. So I can put an oxygen out here, and then I can put in a double bond to that oxygen. And now 1, 2, 3, 4, 5. So this should be 3-pentanone if I built it right. And there it is. So now I have my carbonyl group, and you'll see when you rotate it, it's very flat. Not surprising, because it's supposed to be trigonal planar, AX3, and this is why we did bonding first. And you can make it bigger and smaller when you're trying to look at it. Now let's say I want to make that an aldehyde. Well, for me the easiest thing is, hey, let's get rid of that carbon, let's get rid of that carbon, and maybe I want to add another carbon like that. So 1, 2, 3, 4. So now I've got a butanal. And there it is. So again, I'm just using a previous structure, and I can make what I need to make. Now making esters, that'll be a lot of fun for you. At some point you're going to have to make some ring structures, and they're a bit of a pain at times. So I go around. Let's say I want to put 5 carbons in my ring. Whoops. Let's get rid of that. Didn't want that. So I make sure I'm dragging, and now I want it to click on that end one. And it did. It's closed. You may have to fiddle around with that. 2D to 3D. Boom. So remember, this is definitely not benzene, because first of all, we don't even have 6 carbons. And then I can put branches on. I could put a chlorine here and make a bond to it. And I could do an OH here. So I can do an O and put an H, and now I can link those. So I'll link like that, and I'll link like that, and 2D to 3D, and let's see what we get. And you can see the halogens they like to represent with the green. And you see our bent structure in the alcohol. And I'm just curious if I get rid of the chlorine. And let's see if I replace it with a bigger element. So let's try some iodine. So let's try that. Boom. So I click an I. Now I'm going to link to the iodine. And let's see, does it look the same? They represent the same way? They probably do. You can see, oh, no, they've put in a different color and slightly bigger. Anyways, that's how you do it. I think you'll find it's pretty quick. And if you still like using the spring and ball models, you're welcome to build the structures with those if you find it easier to see. But this gives you a pretty quick representation. In a two-dimensional screen, it does give a sense of the 3D. So I'm hoping that helps get you through this lab.